Waves are an interesting phenomena. It is a phenomena of nature where you can get energy transferring through space without actually having to send matter on the trip. Waves are useful in a lot of different situations. There's kind of an interesting thing that can happen with waves, and that's called a standing wave. And you've probably seen something like this before. If you go and you have a spring or something of this nature, can I get this going? How about a little bit? There we are. There's a nice one. Right there in the middle. You don't see much motion happening, and that's called a node. Now, the nodes are interesting things, interesting places. You can use sound to go and levitate items by going and trying to insert them into the nodes like we saw over there. Here, if I switch to this, we have a very small, can I get that to clear up a little bit? Yeah, this is called a piezoelectric transducer. Big highfalutin words that just mean it's a speaker that screams at a really high pitch. The pitch of this is set at about 40,000 cycles per second. Now, human hearing can only hear up to about 20,000 cycles per second, so you can't hear this. But what I'm doing here is I'm sending sound down. It's reflecting off the table and coming back up. And that's what we had happening over here with the spring. I was sending out a wave, and then the wave reflects and comes back. When that reflection interferes with the wave that I'm sending on down, we start creating a standing wave. Now remember that there are these things called nodes. Where nodes are, there isn't a lot of motion happening, and those places are places where, in this situation, in this setup, matter can hang out. So I have my frequencies generator set at slightly over 40 kilohertz, 40,000 cycles per second, meaning this device is moving back and forth at 40,000 cycles per second. I'm monitoring this up here. So if I go and I turn up the power on this, there we go, come on up, boom, 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 boom. There we go, maximum power coming out through a power amplifier here. This is actually screaming right now at probably about 120 decibels, but it's at 40,000 hertz, so I can't hear it. So this is what we call ultrasonic. Let me scoot this back ever so slightly, see if I can get this thing into a little bit better focus. And I got a little piece of styrofoam right here. Let's see what we can do. See, this thing right now is sending sound down. It's bouncing off of the surface of the table, heading back up and interfering with itself. And so you're creating zones of space that are actually moving back and forth with tremendous speed, 40,000 times a second. The pressure. But then there are places in space where there isn't that motion happening. And that's where this little tiny guy right here, there we go. There we go. So as we bring this on over, whoop, let's kind of bring this down. Pull it. There we are. Let's see if we can get that guy to pick up and float. It's not at the right angle. There we go. Here we are. This little guy is floating off the surface. There we go. There we go. We're able to carry this little guy around on sound. If I turn the volume down, it should drop. If I bring it back up, and I catch it again, Come on. Come on. Come on, let me see. Oh, there we go. I've caught it. And I can keep it inside of that thing. So I move back and forth. I come over here and I can leave it behind. And I can come back and pick the little guy up and move him on over. So this is called acoustic levitation, using sound and sound bouncing back and forth to pick up and move small items. If I had much more power, you could go and show this with several other sorts of things.